Hello friends, in this video we see the topic divisibility in integers. First we see definition, then examples, and then properties of divisibility. Okay, let's begin with definition. Okay. Let a and b be integers with a is non-zero, then the integer a divides the integer b if there exists an integer q such that b is equal to a into q. Means if we get integer q such that b is equal to aq, then we have to say a divides b. And also we say that b is divisible by a. And it is denoted by a vertical line b, means a divides b. This is the symbol to denote a divides b. Okay, let's see the examples. 2 divides 6, since we have integer 3 such that 6 equal to 2 into 3. 3 divides minus 12, since we have integer minus 4 such that minus 12 is equal to 3 into minus 4. Minus 5 divides 10, since we have integer minus 2 such that 10 is equal to minus 5 into minus 2. And minus 7 divides minus 14, since we have integer 2 such that minus 14 is equal to minus 7 into 2. And if there does not exist such an integer q such that b is equal to aq, then we say that a does not divide b, and it is denoted by a symbol a vertical line cross b, means a does not divide b. For example, 2 does not divide 3, since we don't have integer such that 3 is equal to 2 into that integer, so 2 does not divide 3. Okay, let's see some properties. Let a be an integer, then a divides 0, since we can write 0 as a into 0. A divides a, since we can write a is equal to a into 1. 1 divides a, since a is equal to 1 into a. And one can easily prove that a divides 1 if and only if a is either 1 or minus 1, means a is plus minus 1. Let a and b be integers with a is non-zero, then a divides b implies a divides minus b. Let's see its proof. Suppose a divides b, then b is equal to a into q for some integer q, and by adjusting minus sign we can write minus b is equal to a into minus q, and so by definition of divisibility a divides minus b. Similarly, one can prove that a divides b implies minus a divides b, and a divides b implies minus a divides minus b, just by adjusting minus sign. Okay, let's see another property. If a divides b and b divides c, then a divides c. Let's see the proof. A divides b implies b is equal to aq for some integer q. Similarly, b divides c implies c is equal to b into r for some integer r. And so we can write c is aq into r, since b is aq. And so c is equal to a into qr. So we can write c as a into s, where s is product of q and r. Since q and r are integers, their product is integer, means s is integer. So by definition of divisibility, a divides c. Let's see another example, another property. If a divides b and a divides c, then a divides b plus c. A divides b implies b is equal to aq for some integer q. Similarly, a divides c implies c is equal to ar for some integer r. So addition of b and c is aq plus ar, and by taking a common from aq and ar, we get b plus c is equal to a into q plus r. So b plus c is equal to a into s, where s is q plus r. Since q and r are integers, their addition q plus r is integer, means s is integer. And so by definition of divisibility, a divides b plus c. Yes. Similarly, one can prove that if A divides B and A divides C, then A divides B minus C. In general, if A divides B and A divides C, then A divides Bx plus Cy for any integers x and y. And if A divides B and C divides D, then product of A and C, AC, divides to product of B and D, BD. Thank you for watching the video and subscribe this channel for more such videos. Thank you.